Welcome to episode 2 of Recreational Mathematics, part of History of Math 11, the good parts version of math, with a few different activities to stretch your brains with some mathematical thinking. Logic puzzles are a great way to start thinking about mathematics a little bit differently. There have been some famous mathematicians, but also some famous writers who have done some great job with mathematics in non-linear mathematical ways. For example, Lewis Carroll and his Alice in Wonderland series, there's a bunch of different writings around it, have a few logic puzzles around Tweedledee and Tweedledum. He also brings in an amazing mindset around rabbit holes. You might chase a rabbit down a hole, like the White Rabbit, but it's more than just a hole. Once you get underground, you'll see a big warren with tunnels going all over the place. And that's what Math 11 History of Math is able to do. We might start with a simple logic puzzle like this one. After you finished reading it, pause it, and then we'll provide the two answers to the two solutions down below. And you never know where that's going to lead you. The field of exploration math, you don't always know where you're going to end up based on where you start. And yes, playing with historical puzzles and playing games in math is part of History 11. That's the fun part about math. We are looking at the different ways that math gets used to do inductive and deductive reasoning, to make predictions, to do generalizations, reach conclusions drawn from experiences, knowing that everybody's experience may be different than somebody else's. That's the fun part, using manipulatives from all across the time zones, including another one that's going to make us stretch our brain in a couple different ways. So here's another magic eye puzzle to look at, where we are going to try to use our eyes in a few directions down below, so you can pause it and take a look, to try to get unfocused and focus and use some of these mathematical algorithms to see how many 3D boxes you can actually see. It's amazing where math can take us. Is this prime? It's a pretty simple game, but it's amazing how addictive it can be. For example, is 1 prime or not? It actually isn't, because there's not even one number they can divide by. So then we have to start thinking out, and are these numbers prime or not prime? Do they have dividers? Are they on their own? Fortunately, when you get things that have a 5 at the end, that one's pretty straightforward to be able to guess and work with. 3 is prime because it's 3 and 1. Then 87, no, we're gonna go with a no for that one, a yes for that one. So some of them are pretty easy. Some of them take some practice until you get to understand what the prime really is all about. And then you wanna see how many you can get in that 1 minute and see how fast and far you can get, and if you can even keep clicking them all the way through to the 1 minute. Even that is a challenge. Again, at least this time I got 21 different numbers. Primes are a great example of a rabbit hole to go down to. You might think you're just looking at numbers that only are divisible by 1 and itself, but it leads to so many other questions and explorations. Why did cicadas only come out on prime numbered cycles? You're going to go down one rabbit hole and you're going to discover so many different avenues and left turns, right turns, and upside downs that you can go. That's the fun part about math. But make sure you try out, is this prime? I'm curious to see how many you can get done within a minute. Brain teasers are great. Each of these 9 questions have a very solid answer that you can go to, although there are often multiple answers that can go to them. But you can pause it now, and then when you're ready, we'll reveal the answers. Really, this is it, a 9 by 9 table. Couple simple questions. Why is there only 1 digit in each square? And what else do you notice? So many questions can be developed from this. So many patterns, so many things that you'll see that I don't. So take a little look, explore, and think about, what do you notice in this 9 by 9 table? Okay, now we're going to make the brain hurt a little bit. This is definitely a bit more of a trickier problem, as we are going to have you do some work on a piece of paper or in your head, and we're going to have a pie throwing contest. There are 41 kids in this circle. Everybody is filled with a cream pie, and they have to throw a cream pie at the person standing immediately to their left. Who survives the longest without getting a pie in their face? There is also a QR code if you want to see it in practice as well. Pause here if you want to take a little look in solving this type of question. Howie Hua, at least I hope that's how you pronounce his last name, is an amazing mathematician who shares a lot of resources via a cross-section of social media threads. He does a Mental Math Monday thing, and one of the questions I love to look at is how do you count certain things that you look at? And I will freely admit that Mrs. Landy is not a big fan of storing eggs as the number C example would be. Try it out in your household and see how it goes over. I thoroughly believe in showing everybody that there are some math equations that aren't solved. That's right, there are things that we know are kind of right and seem to help make other things work, but we don't really fully understand them. So here is one of the Millennium Prize problems that there is out and about there. Just look at it briefly, get a little confused, and if it makes sense to you, share the solution, please and thank you. But other than that, just be aware that there are some questions that people have been thinking on for a long, long time. It's why rigor is so important in mathematics. Okay, back to more of a brain teaser that'll make you a little confused, and then if you don't see the answer right away, in 2 slides when you see the answer, you'll go, oh, really? Because that's what math should be as well. There should be a few puns in it as well. And as a visual, why math doesn't always make sense. I know I can see black circles. But every time I look at the black circles, they go back to white. Why is it? Why is this mathematically work the way it is with optical illusions and the way the neurological pulses in my brain work? I can see the black dots unless I look at them. Thank you for joining us in this week's Recreational Mathematics. If you are thinking that you'd like to make a submission so that your teacher can give you credit for going through these activities, there is a link below. You can go in, fill in the forms, and yes, the answer to that, what does 6 equal? 6 equals 3, because the missing question is how many letters are in the numbers word. Delightful, recreational. Math can be fun, if not a little confusing and frustrating. It's okay to get frustrated. It's not okay to stay frustrated. Have a great week, and there'll be more next time.